Thank you. Good afternoon. My name is Qian. My partner Jason Qian and I will cover today's data center cloud first presentation. So we're going to talk about OpenSwitch, what that is, and the HPE data center open networking portfolio. I know we all had a great lunch, and I'm trying to get you guys excited and keep you awake. So here's my deal with you. If you keep awake, I have a small present for you at the end of session. But you had to promise me don't fall asleep. Okay? All right. So this is the first slide. Okay. I was an engineer, so I like a Venn diagram. So this slide talks about on the right, disaggregation, which is this here, okay? And on the left side is open source. As you know, data center market has changed, and it came from a more traditional model, which is this one on the left, where you have everything together. You buy the switch, you have the software, everything load together, and it's become somewhere to the right side in terms of architecture. On the right side, you have choice of the hardware, okay? And then choice of software via this thing called the Oni bootloader, okay? Now, with that, give the flexibility in terms of picking the best of breed hardware as well as the best breed software, okay? So if I flip back to the earlier slide, and you can see disaggregation in terms of choice and open source, that all the code that's available for your inspection, for your contribution, and that's open source. So these are two different things. Now, what is OpenSwitch? OpenSwitch is a software running in the disaggregate model as an open system. Now, it also happens to be, it is open source. So it's both open source and disaggregate, and that's what is OpenSwitch, okay? So why do you need OpenSwitch? So this picture shows components into a data center with the open source component. From the bottom, you have physical switch. And the open source version of the physical switch comes from the Open Computing Project we call it OCP. And then later on, you hear my partner Jason Qian will talk about share with the HPE's open data center hardware portfolio, what it looks like, okay? These are the OCP compliant hardware from HPE. So we have that piece on the bottom. And then if you go to the top, it's the OpenStack. And folks are familiar with the OpenStack that is. And this is for private cloud orchestration. Now, underneath that, you have Open Daylight. HPE is actually a platinum contributor to Open Daylight project, okay? And then OVS, very important piece of innovation happen on the server land, where you make the Open vSwitch. So if you care about the virtualization data center, OVS is a key component of it. Now, come back to OpenSwitch, physical switch OS. So you look at data center, open source components everywhere, from the OpenStack, OVS, Open Daylight, and OCP. And you say, why we need OpenSwitch? Well, it turns out, if you look at the important piece of the data center, which is a switch, connect all the server together, provide the east-west traffic as well as from north to south with the traffic going out, they had to go through this device called a switch. And on that switch, you can buy physical white box, bright box hardware, but you don't have a fully open source network operating system running on those switch. So OpenSwitch fulfill that gap in there, okay? I want to talk about why the OpenSwitch is, open source based OpenSwitch is so efficient, okay? So with that, you actually have to look at from the architecture perspective for the OpenSwitch, what the architecture looks like, what are the components that's in there. The first thing I want to say about the architecture is that the OpenSwitch is based on a database type of architecture with things like a schema and everything describing the behavior of the switch in software. So this, first of all, is database. Okay? Now, with database built into structure, computer software application running on top of that can come and go, can die. You can restart, reboot, and the key thing is that the high availability for the operating system is inherently built into the architecture because database is always there. It's HA is resilient, built into architecture. Okay, so that's the first component. The second component is what I call the OVSDB schema-based architecture, and in this very computer term to describe is called declarative configuration. So you declare the intention, what that is, and describe in that precise manner, instead of sort of in a traditional way in terms of how piece, describe how to do things. So in this model, you tell what you want to do, and you set a state for that, okay? So between the old model, how to do the things, this is what, and what tend to be very precise and persistent, okay? Because in this computer way, you don't want to have ambiguity there. So that's the second piece. We call it declarative configuration. That's part of the open switch architecture, okay? Now, if you're looking at the things to the two things on the right, one is called development. The other one is called testing, okay? You're writing code as developers, and then after you finish writing the code, you're testing it, right? Now, with the open switch, we're using different type of paradigm or technology to write, verify the code you write, and testing. And what we use is called a container technology in this Linux world, okay? As you know, container, or precisely Docker container, this is a friend to developer. Because what? If you write a switch software, and you have to buy that switch, and the switch is not necessarily inexpensive, okay? With a Docker container, you actually can write the application there with your laptop because you're mimicking the switch behavior using the container technology. And you can do the same thing, building a large, complex network using the container virtualization to test the whole network. That's the tool that's given to you using the latest Linux technology. So we have all that. And with that, you see, the efficiency, the productivity, and the modern architecture gave to you with the open switch technology, okay? So you may say, why do we care about open source? Why open source? Isn't the open source just cheaper? It's free? Well, yes, open source can be free, okay? But fundamentally more important is much beyond that's free is what I call keep the cost down, okay? Cost in a business sense, if you own an enterprise and business, cost means a lot of things. Cost meaning that you have labor there, do certain tasks. Cost means, say, you want to develop a software. You want quickly turn a requirement into a software where you can use. So what I say cost is time to deployment, okay? In a traditional way, time to deployment take a long time. It could be taking 2 years. You give a requirement, and somebody write the code for you and test it and verify and everything. With the modern technology, what we call the agile development, instead of the traditional way of using what we call the waterfall model, okay? Very structured phase approach. And agile is more the DevOps model, NetOps model, where you have team of the folks working together in an open source structure there, and the things come out very quickly. A community may say, hey, I want this thing done, and next thing you know, this software is being developed, and then you can put it into deployment. So the key thing here, the value to business, one is quality, the other one is the pace of quickly putting things into deployment where you can use that software, and that window has shrunk dramatically. So that's what I mean cost down, okay? Now, I talk about quality. Why quality? Okay, so for those of you in a traditional development model, you write software, you own piece of software, you're the guy who guarding against that piece of software because you're the owner of that. Now, in a community, open source development is a little bit different because software is available, visibility is there, right? Everybody can go there, take a look, inspections of the code. So I want to quote a famous guy who is the father of Linux and who invented Linux, and this guy is Linus Torvalds, a Finnish guy. And he once said, given enough sets of eye, all bugs become shallow. So what he's saying is that because of larger community there, people looking at the code, and then bugs tend to have it's difficult for the bug to stay there. People tend to figure out and inspect and detect that the bug exists and fixing the bug. So that's the other aspect of improving the quality, okay? I already talked about the third bullet, which is the business agility. Quickly turn the software requirement into the code that you can deploy. The last one, I think, is very important for open source, okay? What I call here is mitigates business risk, okay? Company, small, big. You use software, and the software comes from somebody, okay? Somebody who sells you the software. Now, so your company's business depends on the somebody, the vendor, who gave you the software. If the vendor goes out of business, guess what? You're tough luck. Because the money you spend on software is no longer being maintained, involved, so there's no future for that software. Now, with community-based approach, it's different. So as much as, say, HPE Enterprise, we are a big proponent for open source. We're standing behind it. Now, the software and the community behind it, they stay there, regardless whether HPE support or somebody else support it. Okay, so you do have that freedom and the flexibility with the code, because you know the software you get from HPE that's open source based, you can always go back to the community, to the open source, the source of the open source for that code. Could that improve the risk, mitigate your risk, okay? I want to talk about in this new converged data center. So you have lots of server, and you have networking that ties server together. One of the most important tools that's developed is that we will use a DevOps, NetOps tool to using single tool to manage both the server and the networking gear, okay? And one of the most popular tools is called Ansible, okay? And now, Ansible is owned by this company called Ansible, which is bought by Red Hat, okay? So it's open source, Ansible, and it's very popular in data center, the provisioning tool. And OpenSwitch is another open source tool here. So OpenSwitch community working together with the Ansible, okay? So what they came up with is the product called Playbook for Switch. So now you can use this template, okay, for BGP and a Switch playbook, a role, okay? And then combine with the things you define, what do you want to do with that switch, okay? And what switch you want this to populate to, and you combine these two things, and then it produces this JSON file, and it could quickly push this to number switch. Say you have a task, you have 500 switch. You want to provision all those 500 switch. What was the traditional way to do that? You go to each switch, and then you put the configuration, you build the configuration into that switch. So you done one switch. It may take you an hour to do that. Okay, so you're good. You only spend 30 minutes to do it, but that's still 30 minutes. And you have 500 switch, and you can do the number of days and the weeks, finish that thing. And you're getting tired, and you make a mistake. So this thing is going to have a defect in there. Now, with Ansible, it's different, because you use the same template, and they introduce this thing called a variable, okay? The variable being, for example, switch name, the switch IP address, okay? The VLAN for that switch, and specific for particular units, and introduce a variable there. You combine the variable file with the template, and suddenly it becomes a unit-specific JSON configuration file, and you push that to the switch. Okay, as you can see, the process become very automated. Okay, you're a single host. You control this process, and you push this into the other device, and this is a very, very efficient way to configure switch. And by the way, you use the same tool to configure server as well. Now you have truly converged server and networking switch configuration tool for your entire data center. So how powerful that is, okay? So this slide shows how are you managing the network device, so called open switch, open system on that. On the left side, which is here, it shows you all these API that's available. So API, in particular in this case, is REST API. This is a very modern way of programmable interface into a switch or how to control that switch, okay? Earlier I talked about the schema, the OVSDB, the database approach, declarative configuration, all those properties in database, and you just need to have a way to program setting the state of those database, okay? And the thing on the left is the most modern northbound API you can have in terms of programming that switch, okay, using REST API. Now, one in the middle is a more traditional way, using command line interface to do that. So for those of you who are familiar with command line interface, in particular, for example, Cisco iOS, and this is very much just like that. In terms of show command, to configure, I don't know, is any network operator here? Like, for example, how you configure, so you do conft, right? And you do interface, ether 1/0. Then you do IP address, blah, blah, blah. And subnet 25.25.0.0, that's a /16. All those are there, okay? You should feel very much home to that. And on the right side is the GUI. So human are visual person. We want to see things. And to have a picture there to show you, for example, every switch has ASICs in it, there's a buffer in there. And you will look at how the ASICs resource being used in the real time to see the resource usage. And that's what the GUI tool gives to you, okay? Very, very visual and a comparing tool that for you to see the current state of the switch that's in there using the graphic tool, okay? Okay, so you bought a switch, and you're going to tell your boss that I want to buy another 500 switch. Then how do you convince boss that you really do need that 500 switch, okay? And how do you tell boss that the switch you bought last year is being fully used, right? And the bottom line is you need to tell yourself and tell your boss that equipment you bought is being properly used. And when it comes to a time that the switch, the equipment is being fully utilized, you need to buy some more, and you need the data to prove that, right? And the way to prove that is actually understanding how equipment is being used, okay? So very simplistic term, you bought a set of equipment, you want to know what's going on in the network, in that equipment. So you want to collect those data that's running the equipment there, and you say, I want to collect the data and transmit to a remote point such that I can do something with it. And that process is called network telemetry, okay? Telemetry is metering, right? Remote metering, and that's what the process. Gather the data from the devices, network switch, and put somewhere else. Okay, now that's step number one. Simply move the data from your device, collect the data to somewhere else. That doesn't do you any good. You have the data, but you didn't understand what's going on in the data. So that second piece is called analytics, okay? So you need a tool to understand what's going on in the network, right? Is this what kind of applications running? Are you the network under attack or not? And that's a part of analytic part of the thing. And that's that piece, okay? Now, with analysis, then you gain the visibility. That's a third piece. Now you understand, okay, so my network is constantly under attack, so I need to install security device. Or my network the line utilization is at more than 50%. For example, 10 gig, this thing is running at 5 gig. So I'm at run a high peak utilization. It's time to buy another switch. So that's a very important data you can get, okay? Now, it could be scenarios that you have traffic going through the network, and momentarily, there's a elephant flow going through the network, and you understand there's congestion there. Because with that, the traffic is backing up. You want to have a quick way to say, let me rebalance the traffic, send the traffic to a different link or a different node. So those are the actions associated with it, and that's what the analytic tool and the visibility gives to you, because you see what's going on there in real time, and then the set action associated with to react to that thing. And that's what they call the life cycle of network telemetry, visibility, and analytics. And that's what that gives to you, okay? Now, enough said on that. I want to give you the next slide. So this is not my slide. This is from our partner, Broadcom. They did a presentation at the Open Network User Group, and they showing all the activity they are doing with the OpenSwitch, okay? Example being the work in the Broadview technology. That's a network telemetry analytic tool that built into OpenSwitch, and with that you can see how the ASIC is being used, in what condition. That's one. The other area, for example, the open source API, which isolate the OpenSwitch, the operating system, to the hardware, because this is the abstraction layer, abstract from the hardware, such that you can put a different ASICs in there without fundamentally change the software on that. So this open source version called OpenNSL that's developed by our partner Broadcom, okay? Now, other stuff. So for those of you who very much interested in SDN world, the OpenFlow, and there's a work in progress, not completed, ongoing, what we call the OFDPA. So this OpenFlow work architecture being introduced OpenSwitch, okay? As you can see, partner contribution is a huge part of open source, the operating system development for OpenSwitch, okay? So that's just one aspect of thing. Next slide show, okay, so this slide comes from Barefoot. So for those of you who are familiar with OpenFlow, so OpenFlow was invented by this guy called Mike McEwen. He was a Stanford professor. He's invented OpenFlow. So his latest activity is with Barefoot Network, and that's a Silicon Valley venture capital-backed startup company. And what they do is they have this special programming language called P4. And P4 is a special language, software programming language. With P4, you can actually program this ASICs, okay, using software, okay? So this is a very powerful thing, because now you can use software to control the ASICs pipelining, okay? Now, with OpenSwitch, the picture here shows that OpenSwitch run on physical device, and the physical device has some chip in there, whether, say, for example, the Broadcom, you have Trident 2 or 2+ chipset, okay? These are chip, right? Now, if you were to write a driver for that chip using software to describe that, and that gave you a very powerful weapon of testing the behavior of the chip without the chip ever being made. So for those of you who are in hardware engineering, in particular ASICs design, you know how hard, how long does it take to bring up a chip. Start from design and send to the foundry and chip back, and you bring it up for the first time, you say, oh my God, so much mistake I made in the chip design, right? You can cut through that, shorten that cycle quite significantly, in particular testing the chip without even chip being made using the technology called the P4. And the P4 drive is written for OpenSwitch already, okay? So this is another very powerful tool you can have in this new world of disaggregated networking in terms of the tool you have to help you to get things done, okay? So that's not that yet. As you know, that in this world, offering competition is good for you, for end customer, because with the competition, that it can drive down, it give you richer experience. You have choice and a price, okay? So in this case, you have a chip vendor called Qian, who has a develop a chipset with a flexible pipelining. It's called an X-Plan chipset. It's made by Cavium. So they put an OpenSwitch onto their platform using this direct API called Open API XDK. Okay? So this is yet another example of a competitive chipset, leverage open source code, and then produce a competitive offering. Okay? And this is very meaningful in terms of flexible way to program the pipeline. Okay? As you know, the traditional way, you buy a switch and chipsets in there, you say, this is a layer 2 switch, this is a layer 3 router, and guess what? You can make something in between using software programming, and that's what they give to you. Okay? So you can see the line getting blurry between what is the traditional switching and the routing, because what you could do is you using software to control that. Okay? Last but not least, another very competitive offering from the company called Spectrum, and from Mellanox, they make the chipset, 100 gig chipset called the Spectrum. Okay? And Spectrum, a very unique capability of supporting no loss, okay? Using a no loss fabric with virtual output queuing. This came from this company called Mellanox, okay? So this is another example how to leverage the open source operating system and then quickly turn into a chip, into a operating platform where you can use it, okay? So that's another example here, okay? So I have talked about a lot on system vendor, chip, the component, how do we integrate with open source operating system, in this case OpenSwitch running on that. So this is a different angle. This is the end user, just like you, a customer who owns the data center, and how they collaborate with OpenSwitch, okay? So this is the example actually from LinkedIn. This is one of the largest social network companies in Silicon Valley, and this is the presentation from them. And what they share with us is that they actually interested in, it's truly open networking, open hardware. They actually look at the hardware, say, they have their own favorite hardware from different vendor, okay? And what they did is that they actually ported their OpenSwitch on that platform, okay? Even though they're all using Broadcom chipset, in this case, 100 gig Tomahawk, but it's from different white box vendor. They ported myself, okay? As you can see, different part of ecosystem, community, chip vendor, system vendor, end user, they all collaborate there for their benefit. And that's what the open source is all about, okay? So with that, I'm going to introduce my partner, Jason Shed. He's going to talk a little bit more on the HPE Open Network hardware portfolio.
Thank you, Ted. What the words are like the Ted just said is what is changing, right? So actually, what I want to add on is the IT world or IT technology changing faster than anyone else, right? So it talked about the software changing, especially the data center operating system changing, right? He talked about the open switch, right? So actually, we have many choice on the new operating system, network operating system, based on the OCP, right? I show you here like Cumulus and the PK8, right? So how hardware should be changing in terms to run all those open standard operating system, right? Can the current switch run the open operating system? The answer is no. If the current networking devices, like a switch or router, doesn't support OCP, right? They cannot run all those open operating system, right? So HPE, working with our partner, Acton, to release the OCP-based switch named Autoline. So actually, we also work with Foxconn to release the open standard, OCP standard server as well, right? To make all those platforms running the open standard operating system, right? All those infrastructure provide the customer the collaborate with the Linux application tools, right? Like what Ted said, Ansible and some other tools, right? That help the customer, specifically help the DevOps customer and cloud-based application customer to develop the applications. What the total solution that the HPE can provide the customer, right, towards the DevOps or cloud-based application, right? So we provide the customer, in networking side, right, we provide the customer with the OCP-based compliant switches, right? So we name as the Autoline. So you can see that our Autoline, now we released from 1 gig link to the server to the 10 gig link and 40 gig link, and 100 gig and 25 gig link to the servers, right? Then the operating systems, open network operating system side, right? So we already certified the Cumulus and PK8 OS and HPE brand open switch, right? Later on, we will certify some other vendors, right, who are based on the OCP standard operating system. Yeah? Another product or another solution, which is more important, we can provide the customer, compare with the emerging open networking device or software vendors, that is the service. So HPE has global presence of the service, both from the hardware maintenance service, software integration service, and the network design service to the worldwide customer, right? Especially for the large customer, when they have the global site, right? This is the reason why a lot of emerging vendors who want to promote their open standard product partner with HP, because we can provide the customers with the global side, global presence of service. As I just said, right, we already released the OCP standard switch, right? In the outside of the demo booth, you can see the switch, right? Which is named Autoline, right? So actually, the Autoline now, we have the 1G port to 10G port. 10G port, we have the 40G port uplink to the core switch, right? We also have the 10G port with the 40G port uplink to the switch. And also, we have the 25G port can link to the new released 20G port server, right? And the uplink will be the 100G port, right? That covers all the requirement that the data center server farms, right? So the customer here, you have the data center, you have the server farm in your data center. In the server farm, you have legacy 1G server, right? You have the legacy 10G server. But nowadays, you want to move them or upgrade them to the 25 gig server, right? Now the Autoline have the port to link to the 25 gig server. After you visit the booth, the demo booth, and when you listen to the presentation that both Ted and I just present, right? You think about, oh, the world changed to the cloud, changed to the open networks, right? So how about the traditional data center, right? We didn't say that the traditional data center will will stop, right? We didn't see that, right? That means a lot of applications still running on the traditional data centers, like Oracle, SAP, Microsoft Exchange, right? So HPE Aruba, we commit the customer, we will continue support the customer who continue build up their traditional data center based on their traditional data center application, right? Like Oracle and Microsoft Exchange, right? So when the customer say, I want to migrate from traditional data center to the cloud-based data center by using the open standard or OCP standard software and hardware, right? We also can support you by using the autoline switch and the open switch, and also the certified open networking operating system like a Cumulus and the PK8, right? Those customers, why they want to move to the cloud-based data center? Because they want to run the open standard application. They want to use the open standard, OCP standard tools to help them to develop the cloud-based application, right? To help them to do the DevOps applications, right? So we have both teams can support the both sides of the customer. So how do you qualify? How we qualify the customer? Who are the cloud-based? Who want to deploy the autoline, the OCP standard hardware and software, right? I just give you the use case here, right? If the customer want to build up the public, private, or hybrid cloud, right? If they want to deploy the DevOps application, if they want to use the cloud management platform, for example, like HPE Helium, right? They probably are customer or potential customer by deploying the OCP standard hardware and software, right? So HP open standard hardware and software can provide the customer with all key features that the current data center customer want to use. For example, like overlay features VXLAN, right? So the deployment architecture, right, similar as the traditional deployment architecture with the spine and the leaf architecture, right? By using this architecture, the customer can integrate the open standard hardware and software with the cloud-based management system like HPE Helium, right? They also can deploy the open standard tools, right? Like what Ted said, Ansible, right? They also can use the current vendor product, which help the data center customer to deploy the overlay function like a VMware. Right? That means our open standard data center hardware and software support all the current application softwares and management system, right? So you don't need to worry about, hey, I really want to move or migrate from the traditional data center to the cloud-based center. Who can help us? HPE Aruba can help you. We have the large engineering team in the Silicon Valley, right? Led by Ted Qian, right? We also have the biggest support team, TS support team, professional support team, can help you to integrate the two data center or integrate your application together in country, in Korea. With that, I'll finish my presentation. If you have any question, we can discuss either offline or in the Q&A session. Thank you. Thank you.